those we build within those, and those can be like taken care of by the tools, and a report can be generated. So we'll cover that part in the later in the presentations. Now look at like how do we remediate the HDLC processes. So to make the application compliant with all those security standards, proper steps needs to be followed across the HDLC phases. So we'll see what are those here. Say in the project initiation phase, we need to provide some input to the project plan. And then it will be typically the requirements where we define all the requirements and with related to the security. What are all standards needs to be followed. It might be PCI DSS, or it might be OWSP, or the ISO standards. It has to be documented like in the SRS or the system requirements specification, including the non-functional requirements. So security requirements will be more of the non-functional requirements. So those requirements need to be assessed by the auditors and the security teams. So once the requirements have been defined, then we'll go in the next phase. Then we'll see what are the typical architecture and what are the risks for those architecture. And then we go ahead with defining the security implementations for those interaction and the data flows between different components. We need to look at the security design guidelines and the checklist. What are the security design guideline checklist actually defined at the program level. So we'll finalize design to security and audit, and finalize the test strategy as well, including the test plans, etc. So design phase will cover more or less the risk assessment for the proposed architecture. Then what are the implications for those interaction between the different components, including the guideline and of design and the checklist. Then we move ahead with the coding part, where we will comply with the security remediation coding guidelines and checklist, and then the security code review is required, and then the static code analysis and the binary code analysis also has to happen. So what is static code analysis and what is the binary code analysis? I will come later part of the presentation. In the testing phase, we will do the vulnerability assessment, comply with the security testing and guidelines and the checklist, and also what are the security standard has been agreed in the requirements the document, as well as in the design phase as well. Whether the implementation part in line with the whatever the architecture document has been stated. And then we talk on the testing part as well as the vulnerability assessment, and comply with security testing guidelines and the checklist. And before that, we'll go ahead with the penetration testing, and the deployment phase. There are infrastructure requirement as well as the secure deployment guidelines and checklist will be there. So now we talk about the threat model. So if you look at the threat model has actually typical approach of decomposing the application with layered based approach. So the whole model is to find out what are the threats, and then in which each layer how it can be mapped, what are all things need to be addressed in each layer, and determine the risk around the threats and rank those threats, and subsequently we need to finalize what are the countermeasures are there. So threat actually exploits the vulnerabilities, and it increases also the risk, and risk indicate the protection requirements, and protection requirements are made by the safeguards, and safeguards protect against the threat. And on other side, if we see vulnerabilities increases the risk, and the risk again increases the values with regard to the assets have the values. Okay. So this is the typical threat risk model. So when we go ahead in in designing any particular application or developing the architecture of the application, we need to take a layer-based approach when you decompose the application, and each and every layer we need to identify what are the threats. So in some cases, what happens nowadays a lot of tools as well as the third-party products, specifically like e-commerce site, based on the ATG or the Westware commerce. Those always do not require all the threats has to be taken care of in each and every layer of the application. Okay, so we need to first identify in what all layer we need to manage the threats, and then we have to come up with a countermeasure for that. So I'll go through next some of the standards, checklist and guidelines which needs to be followed across the LDLT. Some of the major securities which needs to be considered in the HDLC phase. Here I have identified the input validations, authentications, authorization, configuration management, sensitive data, session management, cryptography, parameter manipulation, and exception management, as well as logging and logging. So this is the design guidelines. Okay, here you see, do not trust the input when it comes in terms of the input validation. We have made a couple of categories, like different categories are input validation, authentication, authorization, configuration management, sensitive data. With regard to that, different security design guidelines have been put. So with regard to input validation, you have put said do not trust input, consider centralized input validation on client-side validation. Similarly, in the authentication, it is more of the partition size by anonymous, identified, and authenticate. And similarly, authorization is use least privilege accounts, consider authorization. In case of the configuration management, there are management use least privilege processes and service accounts. So we do not need to store the credential in plain text. Use the strong authentication and authorization or administration interfaces. Do not use the LSA, that is the another design guidelines. So when it comes to communication channel for the remote administration, then we need to secure that. So we need to avoid storing sensitive data in the web space. Next one is obviously how do we manage around the sensitive data, whether to avoid storing the secrets or encrypt sensitive data over the wire, or secure the communication channel. So these are the typical design guidelines. There are many, all are not possible to cover here, but these are the couple of those. So we need to develop such security design guidelines which needs to be followed in the design phase, and then we need to develop a checklist as well for the design, and we will continue to exercise those whenever any particular application is designed or it is being architected. So these are the one approach which you need to take. So there are other design guidelines as well with regard to the session management, with regard to the parameter manipulation and the exception management. So in terms of the session management, we need to limit the session lifetime and secure the channels and keep the contents of authentication cookies and protect session state from unauthorized access. So this is very important because those who have been developing those web-based applications need to understand how do we manage the session, how do we secure those channels, whether it is to the HTTP or HTTPS, and how do we keep those contents as well as the authentication of cookies. Parameter manipulation, this is very important. We do not need to trust the field. With regard to the trust of the field, we need to validate all the parameters which is coming from the client side, and based on the design you can do that in the UI layer itself. Next is the exception management, and how do we do the unstructured and the structured exception handling. So we have to use the structured exception handling. We do not need to reveal the sensitive application implementation details, nor we should log the private data such as password. So we have to have the centralized exception management frameworks. So then we have the auditing and logging, what are the identify the malicious behavior, know what are the good traffics, and what are the logging and audit mechanism we are having the application tiers. Is across the different application tier, we need to have the secure access to log files and backup and regularly analyze the log file. Then we have the cryptography as well. We do not develop our own, so we use basically the tried and tested platforms, and avoid the key management of those, and store keys in a restricted location. So we avoid key management. We can use the DPA API cycles. Next, we talk about the development checklist, where we'll have the example of some checklist I will be providing here, which will more of the you at the time of development we'll have this checklist validated. These are the checklist we will use that. So one category is the class, and there are the input validation on those. Then there are input parameters are also there, and the cryptography is also there. So this kind of typical checklist we have to get prepared, and then we can follow up and run through at the time of development phase when the code review will go on. So once we have developed the code using the guidelines, then we go ahead and check that through peer review process whether the this checklist are specifically being compliant or not. Okay, so this is again there are different categories. One is the class, one is the input validation, and one is the cryptography. Similarly, few more categories: the exception management and the cross-site scripting and the sensitive data. So in the exception management, few of such checkpoints are over here. So whether code fails early to avoid any unnecessary processing, whether the exception conditions do not allow user to bypass security or the privilege of the code. Within the cross-site scripting, remove the characters or strings that can be used maliciously, that need to be checked. Whether the content type is set as a HTTP header, such as example, whether it is a character set having the UTF-8 or not, and the HTML response, whether it is the text of UTF-8 character set or whether it is a HTML type content. Cookies, whether we are using to store sensitive information or not, or sensitive information are passed as a parameter to URL or get method or is not. So these are the typical Java J2E standards and guidelines. Say avoid throwing exception in a catch block without chaining it with Java applications, and the stack traces can expose sensitive business data as well as making the root cause analysis very difficult. So we need to avoid throwing exception in the catch block. Avoid direct class inheritance from the Java.lang.table. All the exception class will not declared by try and catch block, which could lead to unhandled exception. So similarly, there are other guidelines are as well, how do we do that, declaring the instant variables without the different access type, or how the inner class or the inner class gets access to different fields, enclosing the outer class. And also how when we use the SQL statements, do the JDBC, the prepare statement or the collectible statement over prepare statement, how those should be used and which one should be used. So we need to use the prepare statement and the callable statement, or rather using the plain statement, and this will help in preventing the SQL injection attacks. And this is with regard to the J2E. So where we avoid using the JSP scripts and including those JSP scripts files. So there are different JSP pages should be referenced as like Java objects or authenticated associated with the J2E based scoped bean, and separate the business and presentation logic which could be used for the component reusability and the multi-tiered application principle. JSP business should use also the error handling. Lengthy stack traces can increase the security risk by exposing information that is highly sensitive to businesses. Avoid direct usage of EGB entity from the Java client application, and direct access to the entity bean from the client application will expose the data structure, business functionality, which poses a very high security threat. So action classes should not directly use the database objects. The direct access from action class to database table should expose the data structure, business functionality, which poses a very high security threat. So use a business delegate to perform any business specific operations as well. So avoid instance and static field in an action class. The use of instance and static fields within an action class creates a security breach, as these are the objects for the shared among multiple sessions and thus can lead to confidential data leaks. Next one, there is an sample code with regard to the Hibernate application. So use only the specific Hibernate API to access the database. If really there is any need to use the SQL for the features that are not supported by Hibernate, either use SQL queries defined in the Hibernate XML, or it can be achieved by using through native SQL. So there is an example violation in the remediation that we have got using the statement to execute query. Rather, we should make it as a create query and use that from the bean, and use those typically in the list to get all those specific beans. So next, here is an example of the SQL injection. So as far as the violation is concerned, that in the following example, here the JSP login form where the attacker can enter the malicious command like